Share the screen. All right, so again, I've managed to get quite a bit ahead. So we will probably finish early, maybe considerably early today, in which case I will let you ask questions, and if the questions stop, we can just end early. Okay, so on paper, I was only supposed to go up to 4.4. Well, I'm already past that. Like I'm just about to finish 4.5, right? So I'm a couple of days ahead, it looks like. Okay, so we're looking again for the next exam on November the 6th. Okay, so our exam is on Trig. It's our longest chapter. You can see what's happening after that. The next test, there's only 3 sections, and then the last one, there's only 4 sections. Okay, so this is going to be our most comprehensive, I guess you can say, exam with the most amount of stuff. Okay. So I did a lot of 4.5. I'll do more 4.5. Maybe go back and do something from 4.4, and then I'll let you ask questions. And if that stops, then we're done. Okay. Okay, so we were tackling this kind of a problem. Okay, they give us a graph, come up with the equation of either a cosine or a sine type of function. Okay, and again, for this week's quiz on Friday, I'm very much leaning toward giving you something like this. I will give you a graph, okay, and based on the graph, you come up with either a sine or cosine function. Okay, so what are the things that we're trying to look for in doing that? Okay, so we did 19 yesterday, but a quick review for 19. Okay, how can I come up with a graph just based on that, right? So I would start off with the amplitude. So it goes up to 3 and it goes down to -3. So that tells me the amplitude is 3. The period was pi from there to there, -pi/4, 0, pi/4, 2pi/4, 3pi/4. So the distance from 3pi/4 to -pi/4 is pi. Okay, then I use the formula. The period is 2 pi over b. So that comes out to be a b of 2. Okay, so that says pi equals 2 pi over b. Solve for b. By the way, there's a trick that you can just reverse these two. 2 pi over b is the formula. You can just switch these two, put b equals 2 pi divided by pi, which is just 2. Okay, and then for shift, well, if it's a sine function, sine would start at the origin. It got shifted pi/4 to the left. So for a sine function, y equals 3 sine of 2 parentheses x plus pi/4. Okay, for cosine, cosine normally starts at the maximum. So there it is. It's already at the maximum. So I don't need any shift there. Y equals 3 cosine of 2x. Okay, so that was yesterday. Now, how about 21? So they give us going from 2 to 12. So one period goes from 2 to 12. That's a period of 10. So the period is 10. Plug into the formula 2 pi over b. Okay, the shortcut is you can just switch these two. B goes here, 10 goes here. Okay, so in general, if you have A equals B over C, if you ever get an equation like that, you're allowed to just switch these two. C is equal to B over A. You can just swap them. So I swap here. B equals 2 pi over 10, which is pi over 5. So I know I have pi over 5 in front here. By the way, getting back to that, how would you prove it? You can multiply both sides by C and then divide by A. Okay, so I'll let you look at that on your own, but this becomes more obvious when you put real numbers. Here, so let me show you 3 equals 15 divided by 5, right? So what happens when you switch these two? 5 is equal to 15 over 3, right? And we all know both of those are true. So that's the idea behind this, right? So you're allowed to just swap these two. All right, so the coefficient in front of the x is pi over 5. Okay, now let's see. This gets shifted 1 unit up, right? Because instead of starting at 0, it starts at 1. That tells me there's going to be a +1 somewhere. +1. All right, so what's the amplitude? One way to get the amplitude is maximum minus minimum divided by 2. The maximum is 3. The minimum is -1. Okay, so the amplitude. So a formula for amplitude can be maximum minus minimum divided by 2, which in this case was 3 minus a -1 divided by 2. That's 4 divided by 2, or 2. So the amplitude is 2. So the coefficient in front is going to be 2. So one more time, look over here. The highest y value is 3. The lowest is 1. Or if you start at 1, right? The new 0, so to speak, is 1 because I shifted everything 1 up. So notice it's 1 maximum, 1 minimum, 1. I used to say 0, but now it's 1 because I get shifted 1 unit up. Okay, so it's up 2 and down 2. So the amplitude is 2. Or again, by formula, maximum minus minimum divided by 2. So 3 minus a -1 divided by 2 comes out to be 2. Okay. Okay, and then lastly, shift. Okay, for a sine function starts at the origin, right? So it start over here. But it's now 2, 1. So that's 2 units to the right and 1 up. Okay, so 2 units to the right and 1 up. So A sine B. So I figured out the amplitude was 2. Sine, the B was pi over 5, so pi over 5. And then 2 right means parentheses x minus 2. And then 1 up plus 1. So that's the answer for this one if you're going to write it as a sine function. Okay, it's supposed to be here at the origin, but it's 2 to the right and 1 up. So that's x minus 2 plus 1. Okay, so again, the A amplitude is 2. Okay, I did maximum minus minimum divided by 2. 3 minus a -1 divided by 2. 4 divided by 2, or 2. And again, to get the period, or the B, the distance from here to here, we said was 10. Starts at 2, ends up at 12. 12 minus 2 is 10. The period is 10. The formula for the period is 2 pi divided by B. Swap these two. B is 2 pi over 10, or pi over 5. So pi over 5 is the coefficient. All right, how about if it's a cosine type? Cosine starts at the maximum. Okay. So it was supposed to be with an amplitude of 2, supposed to be up here at 0, 2. It got shifted over here. So 2 went over to 3. That's a +1. Well, we already knew it was a +1 from over here. And instead of x equals 0, it's at 9 over 2. So it looks like this. So that's my answer. So for a cosine function, this is a sine function. Cosine y equals 2 cosine pi over 5, parentheses, x minus 9/2 plus 1. Okay, so that's what that's supposed to look like. Okay, so that's 19 and 21. And again, I'm leaning heavily toward giving you something like that for this week's quiz. Okay. Okay, then show you 23, which is a matching. 23. So you have A, B, C, D, and 1, 2, 3, 4. So how do I do that? Okay, first thing I notice is the amplitude here is 2, and these are a half. Okay, and let's see, this one only goes up to a half. This one goes up to a half. These two go up to 2. Okay, so A and C have to be these two, right? Because the amplitude is 2. So either A or C is going to be this. And likewise, B and D, which only have an amplitude of half, so they can only go up to a half. So that's got to be these two. So B and D are 1 and 2 in some order. because it only goes up to half and goes down to negative half. And A and C are 3 and 4 in some order because it goes up to 2 and goes down to negative 2. Right? So let's try to figure this out. So between A and C, which one is which? Okay, let's see. Sine parentheses x minus pi over 2. So that means it's supposed to start at the origin. Okay, so starts at the origin, but it's shifted over to pi over 2 comma 0. So which one is pi over 2 comma 0? That's this one, not this one. Okay, so that tells me A has to be 4. Okay, so you can mark down A as 4. So automatically by elimination, C has to be 3. C is 3. And let's double check. Cosine normally starts at the highest point, and that got shifted pi over 2 to the right, and that does seem to be agreed with what we have here. Okay, so C is 3, A is 4, Roman numeral 4. Okay, and then what about these two? 1 and 2 are either B or D. Let's take sine x plus pi over 2. Okay, so again, sine starts at the origin, and the origin gets shifted pi over 2 to the left. So pi over 2 to the left, there's a point there, but not over here. So this one must be B. Okay, if I plug in negative pi over 2, I'm supposed to get 0, and that's correct. That doesn't happen over here. Okay, so B must be 1, and therefore by elimination, D is 2. Cosine x plus pi over 2. Let's double check. Cosine starts off at the highest. That would be 0 comma 1/2. If I shift over pi over 2 to the left, that gives me this point. Yes, so that does seem to be verified. Okay. All right, and now I was done with section 5 completely. Okay, I'm gonna go back and do one harder problem from 4.4, then I'll sneak in some of 4.6. Okay, again, time-wise, 4.5, I was only supposed to get up to 4.5 this week, and I'm already finished. Okay, so anything I do from here on is just gravy, just extra stuff. Okay, so I'll introduce some of 4.6, but I want to go back and show you. Somebody asked for 4.4, number 55. Okay, 4.4, number 55 on page 219. How do you solve sine t plus cosine t equals 1 between 0 and 2 pi? Okay, so that involves a little bit of a trick. So 4.455, as always, ignore any dates that you see. Okay, from 0 to 2 pi. So the trick is to move one of the two trig functions over. It doesn't matter which one. So suppose I move cosine over. So it says sine of t equals 1 minus cosine t. And then the trick is to square both sides. So I square both sides. This is sine squared of t. Square this. That's like a minus b parentheses squared. So a squared is 1 minus 2ab, 2 times 1 times cosine t, plus cosine squared of t. Okay. Now, the reason why you want to do that is now I want to change sine squared of t to 1 minus cosine squared of t. Okay. Since we know sine squared plus cosine squared equals 1, okay, so put that over here again. Sine squared of t plus cosine squared of t is equal to 1. Okay, that means sine squared of t is 1 minus cosine squared of t. Okay, that way I just have the single trig function. I only want one trig function, namely cosine. You could have done the same thing with sine. Okay, subtract 1 on both sides, they cancel out. Add cosine squared of t to both sides. So I have 2 cosine squared of t minus 2 cosine of t. Factor out 2 cosine of t. So 2 cosine of t, parentheses cosine t is equal to 1. All right, so by the 0 factor property, either this is 0 or this is 0. So cosine of t is 0 or cosine of t is equal to 1. Okay, x coordinate. X coordinate is 0 here and here. X coordinate is 1, that's over here. Okay, so what are the angles? Pi over 2, 3 pi over 2, 0, and 2 pi. Okay. But we have to check to see which one of these actually works and which ones don't. Okay, not all of these will work. Okay, so we have to plug back into the original sine t plus cosine t equals 1. And let me write it again for reference. Sine t plus cosine t equals 1. Okay, 0 works. Sine of 0 plus the cosine of 0. Sine of 0 is 0. Cosine of 0 is 1. I get 1. Pi over 2. Sine of pi over 2 plus cosine pi over 2. 1 plus 0 is 1. 3 pi over 2 gets crossed out. It doesn't work. The sine of 3 pi over 2 is negative 1. The cosine of 3 pi over 2 is 0. So I get negative 1. Okay, that doesn't work. 2 pi, you know, works because it lands you in the same spot as 0. Okay, so the only solutions are 0, pi over 2, and 2 pi. Okay, so we accidentally got negative 1. You can see what happened. Negative 1 doesn't work, but what happens when you square it? When you square it, it gets 1. So we accidentally introduce a false solution by squaring both sides. By that process, you inadvertently sometimes get a solution which is not really a solution. Okay, so that's that. All right, I will introduce the next section. I won't get that far, and then I'll let you ask questions if you have any. But otherwise, we're done. .6 is on the other trig functions. Starts on page 231. Okay, so we've tackled this before. Tangent, sine over cosine. Secant is the reciprocal of the cosine. Cotangent is the reciprocal of tangent, or you can say cosine over sine. Cosecant is the reciprocal of the sine. Okay, so give you that. On page 232, they give you a chart here. Okay. Everything I have is correct. Might be kind of hard to understand. I'll show you my version, and you may have heard this from your trig teacher. So what are the signs, SIGNs, of the trig function? Okay, I'm only considering sine, cosine, and tangent right now, because secant, cosecant, and cotangent would just naturally follow after that. Okay, if you have a positive number, the reciprocal is positive. If you have a negative number, the reciprocal is negative. Okay, like if I say the number 7, what is the reciprocal? 1/7. They're both positive. If I start off with a negative number, like negative 3/2, the reciprocal is negative 2/3. Okay, so the sign SIGN will match its reciprocal, right? So whenever the SINE is positive, the reciprocal cosecant is also positive. Okay, and likewise, you know, whenever the tangent is negative, the cotangent is also negative, right? So I'm just considering sine, cosine, tangent. You may have seen a chart like this. Okay, the memory trick that trig teachers sometimes say is all students take calculus, which of course is not a true statement, but that's just how you memorize all students take calculus. Since you guys can have a cheat sheet, you can just put this in your cheat sheet. Okay, so what does this mean? All trig functions are positive here. So we're asking which trig functions are positive. So first quadrant, everything is positive. Second quadrant, S stands for sine. So only the sine function is positive, which means cosine and tangent are negative. Third quadrant, the tangent is negative, tangent is positive, which means sine and cosine are negative. And fourth quadrant, C, cosine is positive, which means sine and tangent are negative. Okay. So all of this stuff can be summarized with this, basically. Okay, so if you've already seen this before and you're comfortable with this, just go with that. Okay, now what about all this stuff? Okay, well, we've sort of already gone over these before. Okay, it does look scary. but I would advise you really just to think of sine and cosine. Because once you have sine and cosine, you can always get these, right? Tangent is sine over cosine, flip that. Secant is reciprocal of the cosine, so flip that. Cosec is the reciprocal of the sine, so just flip. So you really want to focus on this. Okay? And then these things, I've already given you some tricks as to how to come up with these by drawing the unit circle. Okay? And I'll show you what I mean. Okay? So, I mean, you can memorize it or you can put it in a cheat sheet. I think that's too much writing for your cheat sheet. Okay. So if you want to know me, myself, the teacher, what do? I don't memorize these. Okay? I can just draw myself a unit circle and derive it from there. Because to me, that quote unquote lasts longer. I can cram stuff in my head just to pass the test and then forget about it when the class is over, you know, and just forget all about it. But if I think of how to get it, okay, if I know how to draw a unit circle, that quote unquote lasts longer, right? So rather than memorize it, I can just draw myself an angle and figure it out from there. Okay. So I'll show you an example of that. Okay. Some things I thought I'd show you. Page 234. This happens to be the graph of the tangent function. Okay. If you want, you can put it on your cheat sheet. So tangent looks like this. The period is pi, not 2 pi, just pi. Has a lot of stuff that goes like that. So one period you can get from negative pi over 2 to pi over 2. So if I just kind of cover everything up, except for that one right there, right? That's a repeating unit. The distance from negative pi over 2 to positive pi over 2 is pi. So the period of the tangent function is pi. Okay, and then of course you can do stuff to it like multiply it by 2, shift it. Okay, so we'll talk about that in time when we need to. And let's see, the other functions I wanted to show you were cosecant in red is the reciprocal of the sine function. Okay? So it does a lot of u, upside down u, upside down u. Okay? Same thing for the secant. Secant has u, upside down u, upside down u. Okay. Again, you don't have to memorize it. I think if you want to just put it in your cheat sheet, you may. Okay, but here are some highlights. We know this is a sine function. Notice that they match there, which makes sense because the reciprocal of 1 is 1. The reciprocal of -1 is -1. Now, what about the asymptotes? Well, there is no reciprocal of 0, right? You can't go 1 over 0. So whenever the sine function is 0, the reciprocal cosecant is undefined. So undefined, 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 right? Okay, and a property of reciprocals, if one number goes down, the reciprocal goes up. Okay, so if I just say some numbers, 2 reciprocal is a half, 3 reciprocal is 1/3, 4 reciprocal is 1/4, right? So when I go 2, 3, 4, the numbers are getting bigger, but 1/2, 1/3, 1/4, those numbers are getting smaller. Okay, so that means when a function goes down, the reciprocal goes up and vice versa. That's why it ends up looking like that. Okay, and something similar for the secant. Again, if you want to just put it on your cheat sheet, you may. Okay, so cosine, again, they match at wherever y is 1 because the reciprocal of 1 is 1. The reciprocal of -1 is -1, so again, they match. And once again, 0 has no reciprocal, so whenever the cosine is 0, the secant is undefined. So undefined there, undefined there, undefined there, undefined there. And again, when one goes down, the other goes up. So sort of like that. Okay. All right. Let me just go through these. So the homework was 1 through 6 and 7 to 35, I think it was. Yeah, 1 through 6, 7 to 35. Okay, so I'm on page 237. Okay, so here are 1 through 6. So So you can look at the recording for those of you who don't have the book and don't plan on getting it. More problems on this side. 238. And let's see, you can see up to 44 there, so a little bit lower. And that's about it because this is 4.7. Okay. Now there's a super big chart here. Okay, again, it looks scary, but you really should just focus mostly on sine and cosine, right? Because once you have the sine and cosine, you can figure these out, right? Tangent, just take sine divided by cosine, flip it to get the cotangent, right? And secant and cosecant are just the flips, reciprocals of these. So your main focus is just on that, essentially. Okay. Okay, so let's talk our way through maybe the evens here because you don't have the even answers for this. Okay, so how about number 2? Tangent is negative, cosine is negative. Okay, so let's think back to our all students take calculus thing, right? By the way, you're never going to have all 3 of them to be negative between sine, cosine, and tangent. One of them's got to be positive. So in quadrant 1, all of them are positive. The other 3 quadrants, only one is positive and the other 2 are negative. Okay, so it just says what quadrant are we in? Tangent and cosine are both negative. If they're both negative, then the other function sine must be positive. That leads me to quadrant 2. Okay, so the answer to 2 is quadrant 2. And reminder, for the quadrants, you're supposed to write Roman numerals. So in other words, 1, 2, 3, and 4, like that. Not the usual way we write 1, 2, 3, 4. Okay, so the answer to 2 is quadrant 2. Okay, how about 4? Secant positive, tangent negative. Okay, so you just have to think, what is the reciprocal of the secant? It'd be the same SIGN, same sign. So reciprocal of secant is the cosine. Okay. Remember, one function has a co, the other does not have a co. Secant, there's no co, so reciprocal is cosine. So cosine positive, tangent negative. Cosine positive, tangent negative, that must be quadrant 4. Right? So the answer to 4 is quadrant 4. Okay, and then how about 6? Sine negative, secant negative. Okay, so what's the reciprocal of the secant? Cosine, we just did that. So sine negative, cosine negative, that means the other function tangent must be positive. So that's quadrant number 3. So the answer to 6 is quadrant 3. All right, so I will do maybe just one of these and then I'll stop. Then you can ask questions, and if not, we're done. Complete the following table. Okay, so how about I'll do 7 pi over 6. Maybe if I have time, I'll do 5 pi over 4, but I don't think I have to. I can save it for tomorrow, looking at the time, how we're doing. Okay, 7 pi over 6. So how do I do that? 7 pi over 6. Okay, so first I draw myself an angle of 7 pi over 6. If you're not comfortable with that, multiply by 180 over pi, right? 210 degrees. So there we go. 180, 210. Draw it something like that. Okay. Since it's a multiple of 30, I'm going to have a 1/2 in there somewhere. Okay, so see that little dot that I have there? I'm trying to determine the x and the y coordinate. Okay, so look across the circle. Does x look like it's halfway or more than halfway? Well, it looks to me like it's more than halfway. If you look at the y, that seems more like it's halfway. Okay, so y gets a half. The other number is automatically square root of 3 over 2. Okay, and since I'm in quadrant 3, they're both negative. So the ordered pair is negative radical 3 over 2, comma, negative a half, if you can't see that. It's negative square root 3 of 2, negative a half. All right, so cosine of t, x coordinate, negative radical 3 over 2. Sine of t, negative a half. Okay, then for the other trig functions, just base it off of that. So tangent is sine over cosine. So negative a half divided by negative radical 3 over 2. Cancel the negatives, cancel the 2's. Okay. I'll show you this trick again if you haven't seen it. If you're ever dividing the top and the bottom by the same number, you can cross them out. So that 2 there cancels that 2 there. So how do you justify that? Multiply top and bottom by 2. So I multiply this by 2, multiply this by 2, those are gone. So I'm left with 1 over radical 3, okay, which you can write as radical 3 over 3. But if you left it like this, that's fine. Okay. How do you go from here to here? Rationalize the denominator, right? Multiply top and bottom by radical 3. And now the reciprocals. Reciprocal of the cosine is the secant. So I flip negative radical 3 over 2, negative 2 over radical 3, which I would accept. But if you want to rationalize the denominator, negative 2 radical 3 over 3. Cosecant, flip the sign. Negative 2 over 1, negative 2. And then cosine of t, cotangent, flip the tangent. See, that's why it's nice to leave it like this. What do you get when you flip 1 over radical 3? Radical 3 over 1, or just radical 3. All right, so that's pretty much it for that one. Okay, so I was going to stop there, folks. Okay, so let me stop there, make a mark as to how far I got. Okay, and I'll check the chat. Okay, nothing in the chat. All right, so you may ask me questions, but if you don't have any questions, we're done, folks, for the day. And I'll just continue from there. So again, Friday's quiz will be something like I started today. I'll give you a graph, and you have to figure out either a sine or a cosine function based on that. Okay. All right, any other questions, please? Pause for a moment. Either unmute yourselves or put it in the chat. Okay, hearing nothing, then we are adjourned. All right, so we're done, folks. So have a good day, and we'll see you next time. Okay, bye.